students, hope you all are doing good. Today in this video we are going to discuss the physical and chemical properties of bases, pH and its importance in our everyday life. Let us start our discussion with physical and chemical properties of bases. If you remember, in the last video I started my discussion with the taste of the food. I said when we consume a food, it can either taste sour or bitter. And it was due to the presence of acids and bases. So the very first physical property of bases is they are bitter in taste. When you are going to taste a base, it will taste bitter. The next property is they are soapy to touch. When you are going to touch a base, you will see it is soapy. The next time you go to a lab, try to touch dilute sodium hydroxide. You will see that it slips on your fingers just like a soap, and that is why the physical property says that it is soapy to touch. Alright? The next physical property is they conduct electricity. Now, what conducts electricity? The presence of ions, and the bases can dissociate into ions when in solution. For example, say NaOH. And you can see sodium hydroxide when in water dissociates into sodium ion and hydroxide ion. And these ions are responsible for the conduction of electricity. So we can call them electrolytes. Right? They are electrolytes. The next physical property is that they are corrosive in nature. Not all bases, the strong bases are corrosive in nature. Just like acids, they can also create burns or they can corrode the skin. So the four physical properties are bitter in taste, soapy to touch, they are electrolytes, and the strong bases are corrosive in nature. Now I have added a point over here which says bases soluble in water are called as alkalis. You will read a line in your book related to this, which says that all alkalis are bases but not all bases are alkalis, because all the bases cannot be soluble in water, but the ones which are soluble in water are called as alkalis. Now let us talk about the chemical properties of bases. In the last video, we have already seen how the indicators react with bases and give various colors. So we will talk about the next chemical property, which is how metals react with bases. Just like the acids, when base react with metal, they give salt and hydrogen gas. Let us take an example. Say zinc reacting with sodium hydroxide. When zinc reacts with sodium hydroxide, it again displaces hydrogen from sodium hydroxide and forms sodium zincate and hydrogen gas. Sodium zincate is the salt. Zincate is ZnO2 2- and sodium is Na+. So you can make the formula like that, Na2ZnO2. And there is an evolution of hydrogen gas. Now how can you test the presence of hydrogen gas? The burning of hydrogen gas produces a pop sound, and this pop sound confirms the presence of evolution of hydrogen gas. So whenever a base is going to react with a metal, it will form salt and hydrogen gas. Now let us move on to the next chemical property. It is the neutralization reaction. What was the neutralization reaction? That when acids react with bases, they form salt and water. So let us take an acid, say hydrochloric acid, reacting with a base sodium hydroxide. What are the products? The products are a salt, sodium chloride and water. Similarly, when another acid, say nitric acid, reacts with potassium hydroxide, it again forms a salt, potassium nitrate and water. So in both the reactions, we can see whenever a base is reacting with the acid, it is forming salt and water. This is what kind of reaction? Neutralization reaction. and neutralization reaction is double displacement reaction. The positive reacts with the negative, forming what? H2O. Again, the positive reacts with the negative, forming the NaCl. So, whenever there is exchange of radicals, it is double displacement reaction. So, these reactions are kind of double displacement reaction already studied by you in chapter number 1. The next chemical property of base is when bases reacts with a non-metal oxide, they form salt and water. For example, take a non-metal oxide, non-metal carbon, oxide CO2, right? So, a non-metal oxide CO2 reacting with the base calcium hydroxide forms calcium carbonate and water. So, calcium carbonate is your salt and water is again formed as a product. So, if I compare this reaction with neutralization reaction, where acid reacts with base to form salt and water, you have a similar structure. You have a base, you have a salt and you have a water. So, what can you say about non-metal oxides? A non-metal oxide is acidic in nature, correct? Because you have in this reaction base, salt and water. So, we can compare this non-metal oxide to the acids. So, we can say that non-metal oxides are acidic in nature. So, these are the chemical properties of bases. And always remember, the acids and bases show their acidic and basic character only in solution. Now, let us discuss pH and its importance in daily life. What is this pH? As you know, when you are going to add acid to the water, it will dissociate into ions, producing H plus ions. When you are going to dissolve base in water, you will get OH minus ions. So, the concept of ions can be related to a mathematical value, that is pH. pH is the negative log to the base 10 of hydrogen ion concentration, or you can say that it is inversely proportional to the H plus ion concentration. So, this pH tells you about the strength of the acid or a base. The letter P in pH stands for potence, which is a German word meaning power, and H stands for hydrogen ion concentration. So, pH is giving you the power of hydrogen ion concentration in a solution. Based upon the concept of pH, a scale was devised known as pH scale. It was devised by Sorensen in 1909. This pH scale ranges between 0 to 14, and this scale is going to tell you whether a given substance is acidic in nature or basic in nature. Now, for example, if you have a pH less than 7 on this scale, then it will be acidic in nature. If pH is equal to 7, then it is neutral in nature. And if it is greater than 7, then it is basic in nature. A skeleton of pH scale can be shown like this. This ranges between 0 to 14 with a benchmark say 7. So on 7, the substances are neutral. Below 7, they are acids. And above 7, they are bases. Also, on decreasing the pH, the acidic strength will increase. Whereas, on increasing the pH, that is from 7 going towards 14, the basic nature will increase. Thus, we can say, lower the pH, the stronger the acid. And the higher the pH, the stronger the base. For example, if you have two substances with pH 8 and 12, so which one will be more basic? Right, the pH with 12. Similarly, if you have two substances with pH 1 and 4, And I ask you, which one will be more acidic? Right, the pH with 1, because lower the pH, stronger is the acid. What is universal indicator? Normal indicators like litmus do not tell you about the strength of the acids or bases. They merely indicate whether a given substance is an acid or a base. But a universal indicator, which is a mixture of several colors, that is, it is a dye which indicates the strength of the acid or a base based upon the concept of pH. When the pH of the solution is 0, then it gives a dark red color. Now when the pH shifts from 0 towards 7, this dark red color keeps on fading. And when it reaches a pH of 7, it gives a green color. Now when the pH shifts from 7 to 14, the color again changes. It shifts towards blue or purple. That is, for a pH equal to 14, the universal indicator will give you a color which is violet. So the change of the colors on universal indicator gives you the pH of the given substance. Hence, you can determine the strength of the acid or a base from a universal indicator. Now let us talk about the importance of pH in daily life. First of all, we'll talk about plants. How the pH of the soil affects the growth of the plant. Most of the plants grow well in a neutral soil. That is, when the pH is equal to 7. Now, it might happen that the pH can shift. That is, it can go to basic or it can go to acidic. That is, greater than 7 or less than 7. In that case, you are going to neutralize the soil. How? If the pH is greater than 7, that is, the soil is basic in nature, then you will add an acidic fertilizer to it. That will neutralize the soil. Similarly, if the pH of the soil is less than 7, that is, it is acidic in nature, then you can add some mild bases like calcium carbonate, calcium hydroxide, calcium oxide to your soil, because all of them are bases, and this will neutralize your soil. That is why you must have seen that many of the farmers add chuna. Chuna is what? Limestone. Limestone is a base. And why they are adding this chuna or limestone? To make their soil neutral. Now, the next question on the board asks you, are animals sensitive to the pH change? The way the soil pH was important for the growth of the plants, similarly, is the change of the pH will affect us or other animals? So the answer is yes. Our body works under a range of pH between 7 to 7.8. If there is any disturbance in the pH range, then you can have many diseases. There can be many ailments that can occur in your body. So the maintenance of pH under the range 7 to 7.8 is necessary for our human body. Similarly, you must have heard about acid rain. Like you would be hearing that the marble of Taj Mahal is getting yellowish, and this is due to acid rain. So when the pH of the rains falls below 5.6, then such a rain is considered to be an acid rain. Now what happens? You know that there are many oxides present in the atmosphere, like sulfur dioxide, carbon dioxide, nitrogen dioxide, and many other. Now when it rains, these oxides get mixed up with water and they form their corresponding acids. How? SO2 combining with H2O can give you either sulfuric acid or sulfurous acid. Similarly, carbon dioxide when mixed with water produces carbonic acid, and NO2 when mixed with water can either form nitrous acid or nitric acid. And when these acids mix with water, they are going to make the rain acidic. And when the pH will fall below 5.6, such a rain is called as acid rain. Now why is it so harmful? One, we have already seen, it is deteriorating the quality of the monuments. Also, when this rainwater, when this acid rainwater is going to the rivers, ultimately they go and they are washed off to the rivers, and there you have aquatic animals. Now these aquatic animals are also adjusted to certain pH. When this acid rain reaches the rivers, the ponds, the pH of the water changes, and it also creates problem for those aquatic animals. Hence, we can say that this pH not only plays a role in plant growth but also in the life of humans and other animals. Now, what is the role of pH in our digestive system? As you all know, when food reaches the stomach, there is secretion of gastric juices containing hydrochloric acid. And this hydrochloric acid is very necessary for the digestion of food. The pH of this hydrochloric acid is around 1.2, such a low pH and hence a very strong acid. But what happens when there is excess of HCl in your stomach? And it can be due to various reasons like wrong food habits or overeating. So that can result into excess of HCl in your stomach, and that can lead to indigestion. Now whenever you complain about acidity, your mother tells you go and have ENO or go and have Pudin Hara. Now what is there in this ENO? What is so special about this ENO? These ENOs are your antacids. What are antacids? Antacids are nothing but mild bases. They are your mild bases. When you have excess of acid, what is going to neutralize it? The neutralization of this acid can only be done with these mild bases. If somebody is thinking we can have strong base, please don't go for it. Now let us talk about how a change in the pH can cause tooth decay. As you know that your tooth enamel is made up of the hardest substance, that is calcium hydroxyapatite, which is insoluble in water. But when it is acted upon by acids, it can corrode. Now whenever you consume a sugary substance like ice creams, chocolates, toffees, etc., what happens? The bacteria in your mouth start feeding upon it or acting upon it. And this leads to the formation of acids like lactic acid. Now when the pH of your mouth will fall below 5.5, when the pH of the mouth will fall below 5.5, the tooth decay will start. That is, there will be corroding of this tooth enamel leading to the cavities. Now how to get rid of it? Very easy and simple solution. Brush your teeth twice a day. Everybody tells you to brush your teeth twice a day. Why? Because the toothpaste is basic in nature And when the pH is falling below 5.5, it is going towards acid. It means it has to be neutralized. To neutralize it, we are going to use a base. So the toothpaste, which is basic in nature, will help you to get rid of this tooth decay. Let us talk about the self-defense by plants and animals. Many of you would have experienced an ant sting or a honeybee sting, and you must be knowing about the pain and irritation it causes. Why is there this irritation? Why is there this pain? It is because when an ant stings or a honeybee stings, it injects an acid called as methanoic acid. Its common name is formic acid with the formula HCOOH. So with the injection of this acid into your skin, it causes a lot of pain and irritation. Now how to get rid of this pain and irritation? It's an acid, so you want to neutralize it. So again, you can make use of a mild base. The mild bases can be sodium hydrogen carbonate. That is your baking soda. So if you have baking soda at your home, you can go for it. Otherwise, you can go for a soap. Soap is also a mild base. So next time, whenever you get stung by an ant or a honeybee, apply a soap or baking soda. Similarly, there is another insect which is wasp. Now what does wasp does? Wasp, when it stings, it injects an alkaline solution into your skin. So again, there will be pain and irritation. Now to get rid of this pain and irritation, you can go for an acidic solution. You can use a mild acid like acetic acid, which is present in vinegar, or you can use lemon containing citric acid to get rid of the injection of alkaline solution into your skin by this particular insect. Now, how do plants make use of this pH for self-defense? Have you ever heard about the nettle plant or a dog plant? Nettle plant is a herbaceous plant which is usually found in wild or forest-like areas. Now what happens when accidentally somebody touches the leaves of the nettle, they sting an acid into the skin of the person, and the acid is again a methanoic acid. So that can again cause pain and irritation. But nature is very beautiful. Beside a nettle plant, you may find a dog plant. Dog plant leaves are basic in nature. Alright, so these can help you in neutralizing the effect of the methanoic acid injected by the nettle leaves. Thus, the nettle leaves are acid in nature, the dog plant leaves are basic in nature. Therefore, you can rub these dog plant leaves on the infected area and get rid of the pain caused by the nettle leaves. So next time, you all know what to look for if accidentally you are rubbed by nettle leaves. So in this video, we talked about the physical and chemical properties of bases, pH and its importance in our daily life. I hope you all have understood. Thank you.